expire quickly, some of them later, depending on what analytes that you have in your sample and how stable they are. Okay, so let's go through the notes. Okay, now, once again, the maximum holding time is a keyword. So whether or not you're going to see this in your final test, it's not even a question, it's a must. Because these are the keywords that always pops up whenever we collect samples for analysis. So whenever you have environmental sample for analysis, these are the most important thing that you have to determine. Yeah. Okay, so that is the length of time the sample can be stored after collection until they are being analyzed. So that is a time frame. Different analytes, they have different time frame. Some they can last longer. Like for example, if you're talking about heavy metals, you can wait as long as you want with some condition. But some analytes, like the organic compound, the volatiles, especially those that are photosensitive, they are sensitive to light. Whenever they got receiving sunlight, and sometimes even the light from the indoor lighting, they emit UV. They will destroy your analyte. So when your analyte is destroyed, it's no longer valid. Your sample is of no use. So these are the things that we have to be very mindful and very, very careful. What are we looking into the sample? And we have to tell ourselves, am I going to analyze these samples as quick as possible, or do I have time to wait because they're stable? So here is what we're going to learn today. By the way, this part, maximum holding time, is a key piece, one part that the QA team, the QA, like I said, the planning part. Kan? So you have to plan what you want to analyze, and you have to ask yourself, hey, is this one can wait? Can you wait until tomorrow, then you analyze? Because simple, kan? Because on that day of the field trip, you're going to come back into the lab, and by the time you reach as FSG lab, you want to return the equipment and you want to store your water sample. It's already 4 p.m. Of course lah, the lab is not going to open after 4 p.m. kan? So you have to wait. That is a big question kan. How long can you wait? Because every sample may have their own different maximum holding time. And this maximum holding time, for your information, also depends on the authority. Like here, there are several jurisdiction according to US EPA, which is in Malaysia, it's equivalent to Department of Environment. ASTM is their standard organization, more or less like SIRIM lah in Malaysia. USGS is the Jabatan Mineral and Geoscience in Malaysia lah, that overlooks the groundwater and also mining things. And APHA is the organization American. I forgot what is, but it involves more into health science, if not mistaken. APHA. Later you can find out what is APHA. And the most important thing is our standards. A lot of our standards are referred to APHA rather than US EPA. So these are the things that you have to be mindful of. For water quality monitoring and standards, most of them we refer APHA. Okay, now the good news is they are more or less the same, but there might be some difference. So always refer to the authorities that have oversight onto the monitoring program, especially in river. So in Malaysia, I forgot to tell you last week when I started discussing about this river or surface water monitoring. While earlier I have introduced JMG, Jabatan Mineral and Geoscience, Department of Environment, but I forgot to tell you one organization called LUAS, Lembaga Urus Air. Forgot what is, but LUAS lah. Now, for the water group, if you're listening this one, remember to find out what is LUAS, LUAS, because that organization is the one that has authority on the river water sampling. Yeah, in terms of sampling, they are doing the sampling. Okay, So you have to remember, yeah. Actually, whatever that we're going to do, kan, in terms of river quality, river water sampling, this organization, LUAS, has to be contacted and ask them. Yeah. Because when we talk about in Malaysian context, lah, when we want to monitor river, LUAS collect sample, DOE analyze it, or if DOE can analyze it, they send it to Department of Chemistry. Okay, so these are the tables that you have to get familiar. So according to APHA, the maximum holding time for water quality monitoring, these are the parameters. There are so many parameters, but the good news is for your field trip, you just need to focus on six lah. The six that you can calculate water quality index. So tell me, what are those six parameters? You still remember the six water quality parameters for Malaysia lah. Ingat tak? Anyone can switch on the microphone and just tell me lah. It's in here. You just need to tell me. Apa dia? You all following ke tidak ni? No response at all. Water quality parameters. Don't make me answer my own question lah. You all respond sikit, or I make you all open your camera. Still no respond. Payah lah. If I want to teach you this thing, I don't even know if I'm talking to you or you just come in here, you switch off your camera and you're not even listening. Are you all listening?
Yes.
So you dapat
Yes.
soalan tu kan? Okay. So one more time, the question is, tell me the six water quality parameters. Tell me.
Temperature.
Temperature is not six.
So, is it COD, BOD, TSS, ANNH, VSS, and is that all?
Mostly are correct. I think you missed the PHDO.
Oh, okay, pH.
Okay, now this is serious because I think that most of you here are also taking water resource technology. Kan? These are the six parameters that you can hafal sebenarnya. If not for your EVT 525, EVT 536, you also listen. Okay, so this is not good. That means your basic pun belum ada. Okay, never mind. Last week dah sebut. This week I check again. Okay, actually the purpose of me asking you this question is not because I thought you know. I just want to check your response so that you tak tertidur kan. Okay. Here, number one, pH. Okay, pH, DO, pH and DO. These are the two water quality parameters that you have to measure immediately. No waiting time. So that's why we are bringing the multi-parameter probes, in which you celup that alat. Last week I shown you that probe. Put it inside the river water, straight away you can get the reading. pH and DO are the two readings that you have to take in order for your report lah, because you want to calculate water quality index kan. Now there are other things that the probe can also measure, like salinity, temperature. Well, that is part of the data that is presented to you. Even though you don't need it, you snap picture or you use the data logger. Okay, data logger is the equipment that is in the central panel that have memory to store it. I prefer you to take picture lah. Every time you do a reading, ambil gambar and then you catat. Okay. So two, another four, where are they? Another 4, which is DO. Oh, no, DO. BOD. COD kat mana? COD kat tengah ni. Okay, BOD is the other one. Turbidity is another. So two water quality parameters sitting in the second column. Another 2 is here, ammonia, nitrogen, and also COD. So you can see kan, in water quality saja, out of those 6 parameter, they have different maximum holding time. So water group as well as the QC team member that is attached to the water group, these are the things lah that you have to put inside your plan. So that after this, you know what to do lah. You go to the site, you use a probe, you measure the pH and then DO directly. No more waiting. You cannot measure after you take back the water sample. The others, maybe you have 6 to 48 hours, 7 to 28 days. But of course lah, we only have 2 more weeks to analyze your water sample. And yeah, these are your reference. Okay, now that is for your sampling and analysis plan. But what about your final test? Students, listen carefully. Your final test, I will cover this one, definitely. Too important not to cover. You want to half-file everything? I don't know, but you start with the important ones, okay? Like water quality index, 6 parameter. Why I ask you so many times, you faham je lah kan? Okay. All right. Okay, before I continue, do you realize that there are certain parameters that you need to measure immediately, some that are later? Like I told you, kan? If we are going to analyze heavy metal ni, you cannot destroy it. So it was still inside your water sample no matter what. So make it, if you want to wait for 6 months, it's still going to be inside. It's not that that metal boleh meruap. It won't turn into gas. It will stay inside the liquid. But do you still remember from last week, how do we preserve the water sample? Let's say you just want to know the metal content and the metal is stable inside the water sample. How do you preserve? By the way, you still have to preserve that, even though the maximum holding time for metal is very long time. They're stable, but you still have to preserve. But how? Anyone? How do you preserve?
Chiller.
Chiller, and you have to put something inside. Not just chill at 4 degrees Celsius. Yes, the answer is correct, but you still have to add a preservative. What is that?
Acid.
Well, what acid? Which one?
Sulfuric acid.
Sulfuric acid is not correct because sulfuric acid is for ammonia.
Nitric acid.
Yep. So remember, acid, so many types. Heavy metal, nitric acid. Ammonia, sulfuric acid. But here's one thing that I also need to remind you, and I just found out that COD, last week I told you just chill it kan. But apparently COD also was recommended that you add preservative, and that preservative, fortunately is the same with ammonia. So COD here also preserve with sulfuric acid. Okay, now don't trust me. Why not? After this, you double check with Dr. Nick and you ask her for COD ni, you need to preserve or not. So if you need to put preservative, adakah benar sulfuric acid? I know for sure ammonia is sulfuric acid, but COD I tak sure. You double check for me. Okay, so water group, don't forget, adakah you want to put sulfuric acid as your preservative? So when we look back at the middle here and also the one that you need to analyze immediately, the reason is simple because pH, DO ni, and temperature, they change very fast. So whenever the parameters that you want to measure is subjected to very fast changes, then you don't have a choice. You have to have a meter to measure directly. No time to bring back to the lab. If the moment you bring back, it will change immediately. Yeah. So that goes to the next one lah, whatever the analytes. Now these analytes, there are some too unstable. Either they're too unstable or they are the nutrient that is constantly being uptaken by the bacteria and also the microbes inside the water. So they also change relatively quick, but maybe you can buy some time because as long as you chill it, the microbe stays inactive. So you have extra time lah. Now, the other things that may not be metabolized by microbes, you have a bit more time, but still, the third column right here, you can see most of them, they are organics. They are either unstable because of the effect of the light, or maybe they are volatile. So here you go. Maximum holding time ni, they are also subjected to a proper QC. QC means how do you collect those water sample? How do you preserve it? And do you need to use a proper containers with or without headspace? These are the things that you definitely need to be mindful whenever you prepare your sampling plan. Okay, the preparation of sampling plan, which comes under the QA team. Q and QC, they are separate lah. Okay, so I think I've done with whatever that I haven't covered from last week. So here is the beginning where the QA and QC team need to be very prepared and alert lah. So Q and QC team, I assume that you're already here, so you pasang telinga tau. Because after this, whatever that I'm going to teach you about field quality control and quality assurance, QC and QA is your job, your responsibility, and it's extremely important because we're going to start with sampling and analysis plan kan. That is your output. That is your output. You have to ensure that each group they are doing it properly. As an advisor, you have to check their procedure lah, yeah. Okay, 70 students, not even all here. Okay, so next slide. Okay, so here's the introduction. Why do we need to be careful with QA and QC? Well, it's as easy as what you saw just now in maximum holding time. I already told you that these analytes, some of them, they are not stable. They're subjected to changes. Now, if these changes are so big, how do you trust that your data are accurate or precise? So it's mostly because of the accuracy and the precision of the data that we are so particular that we have to make sure that our data is trustworthy and reliable. So in order to ensure the high reliability of our data, it has to be correct. It has to be accurate. It has to be precise. And QA and QC is here to ensure that. If you can't ensure it, at least you are moving to that direction. Okay, why? Because here error is anywhere, unfortunately. Like for example, variation due to the time changes, or maybe the space changes, or maybe the water samples may change the quality of your analyte. It's part and parcel of the environmental samples. It change all the time. Okay, so in order for us to capture the accuracy of our data, we need to make ourselves as much as possible. We avoid contamination. Right here, contamination from where? You might ask. It can be from the matrix itself. Even the water sample itself may have some contaminants that may cross over to other water samples. It might be the contamination coming from other metrics, like for example, the soil sample, right? You go to river is not just water. The bed of the river, you have sediment. The bank of the river, you also have soil. The moment you jump into the river, you already started the contamination by increasing the suspended solid, for example. Okay? So this contamination can be from anywhere. It also can be from yourself, your hands. Yeah. your breath, for example, if you're into microbiology analysis, every time you breathe out, you also introduce the germs or the microbes into the water. So these are the things that, depending on how accurate and how precise you want your sample is, a lot of QA and QC may be subjected. They may not be the same, so you have to figure out the entire process. Yeah, the entire process of your sampling and analysis. Yeah. Okay, so cross-contamination might affect the accuracy and precision, but also the other factors like improper preservation. Like I told you, if you forgot to put in sulfuric acid, for example, if you forgot to put in sulfuric acid into your water sample that you want to analyze ammonia, ammonia might turn into something else. Like, for example, ammonia can be oxidized to nitrate. It's a different thing. It's undetectable if you want to determine the ammoniacal nitrogen experiment. And also, ammonia, even though they don't change, if you forgot to put sulfuric acid, the sulfuric acid may not capture the volatile version of the ammonia, so they might also escape. So these are the things that preservative can do to hold your analyte, and also some preservative might kill microbes that change the water parameters. Okay? So there are a lot of things. And of course, like I told you, the earlier tables, be mindful. And of course, and also the last one, the lack of representativeness. So these are the design of the sampling plan. Okay, representative is how many samples that you want to collect, samples that you want to collect that represent the entire body of the area that you want to analyze. Like, for example, now that you want to go to Sungai Tua, for example, the river is very long. So how many samples and how are the distribution of the location of the samples that you want to collect and also represent the condition of the entire river? Quite tricky, isn't it? You can't really sit on one spot. You collect the sample in that spot and claim that you represent the entire river. That is not possible. Because by right, you have to collect as many samples as possible, kan? And that as widely distributed as possible. These are the challenges for us who wants to plan this sampling, because we can't take too many samples, but yet those samples have to be adequate, okay, not too big, not too small, enough to represent it. So these are the things that the QA and QC team needs to be mindful of. But basically, in order to represent the entire body, the sampling size have to be big enough. Okay. So I will move on to QC. So let me show you all the text right here. Now, like I said to you earlier, QC is, you can equates to the protocols or the procedure or the technical aspects that you will carry out. Okay? So you can see that these are the things that you do in order to prevent error from happening. So in this case, you will have a program which is the result from the quality assurance program planning. So these are the planning that you will do in order to execute this QC program. So it all starts with QA. And this is exactly what the QA and QC team is doing right now. Now, one thing, for example, you are preparing your sampling and analysis plan. So you're still in the planning stage. The documents from that planning stage is sampling and analysis plan. The plan itself is the result of the QA, quality assurance. So QA and QC team, what you're doing right now is at the QA stage, you're planning. Okay. So by the time during the day or a few days before the field trip, you're preparing the bottles, you're washing it, you are introducing the field blanks or whatnot. These are the hands-on things, the procedure that you're doing, and that falls under QC. Okay. So assuming that you know what is going on here, okay, continue with the next one. So these are the parameters that will help evaluate the source or the variability of the error, in which there are 5 of them. Now, these 5 parameters are extremely important for Q&QC team because these are the ones that you will need to document it based on these 5 parameters and also the sampling activity that you're about to carry out. How best you will plan the QC program in order to meet the requirement of these 5 parameters. So I'm not sure, I'm sure you know what those means, right? Precision, accuracy, representativeness, like we have explained earlier. Completeness and also comparability, later I will explain lah, yeah? Okay. So by meeting all these 5 parameters, only then you have some confidence lah, yeah? To be able to claim that whatever the data that you can generate from the samples that you collected are defensible and they have some degree of reliability. You can rely on those data because you trust that based on the QA and QC program, you meet these all 5 parameters, and you can trust the data that you have analyzed and generated from the samples that you collected. So, okay. I think this one that I did not explain to you earlier, representativeness. So representativeness is what you can see right here, the extent which measurement actually represent the true environmental condition or population at the time of the sample was collected. Like I told you earlier, the river of Sungai Tua is quite long and quite big. How do you ensure that your sampling design meet this requirement? In order to meet this requirement, you have to sample, as many points as possible, okay, as distributed, as well distributed as possible, and as many samples as possible. Theoretically, it's like that, kan? But can you do that? Okay, earlier, last week, there's a student who asked me how many sample bottles do we have? Can we buy new one? Okay, water group, listen carefully. We don't have budget to buy new bottles. Whatever the bottles that you can find in B219, you just use that. And I believe that there are around 30 plus minus 30 lah, 30 bottles or maybe more than that you can use. But find out with Puan Use. Puan Use, because other students might use it for their final year project, so you have to be very early and very quick. As early as possible, book with her how many sample bottles that you need so that you can answer and meet this requirement, the QC requirement, yeah, representativeness. Okay, now that is for your field trip. But if you're into another situation, like for example, this picture right here, you see a lake. Lake, depending on the depth of the lake, also have stratification. So based on the stratification, if it is near to the surface, it's more oxidized. If it's near to the bottom of the lake, it's less. The different condition also will change the water properties or the water quality. So because of that, you want to represent the entire lake. So you have to collect water samples at different stratification, different depth. Then only you can like discuss more accurately. Yeah. Because you can't take the surface and represent the entire lake. It's not. Deeper in the lake, the quality is different. Yeah. Okay, so these are the things. Okay, next one is the completeness. Now, completeness is another different story. It means the percent comparison between the amount of data intended to be collected versus the actual amount of the valid usable data collected. Okay, do you understand what this means? Faham tak that statement? Boleh faham ke this statement? Ada response ke? Completeness, first point. Faham ke? Sure.
Faham betul.
Okay. Well, based on the statement itself, it states that you want to collect this and also you ended up with another number of samples. So the logical thing right here lah, is that what they're trying to say is that whenever you go to the sample site, the field trip, the sample site, you may not going to be able to collect the same number that you have planned. So planning another thing, collecting is another. Why? Tahu tak kenapa? Why you may not going to collect the same number and that number is usually lesser than you plan. Tahu tak kenapa? Do you know why? Do you know why you always collect less sample than you initially planned? Tahu tak kenapa? What are the possibility that you collect less than you planned?
Not enough um, hmm, sampling punya collector.
Not enough sampling collected. Betul, but it's due to many factors kan. You collect less because of other mishap kan. Like for example, the classical ones lah. You pergi sana and you want to collect 30 sample, then suddenly there's one of your team member terlupa nak bagi tahu, oh yang dapat pinjam sample bottle hanya 25 saja. Example lah. It could be many reasons now. That is one, due to miscommunication, human error during the planning and execution. So let's avoid that. You guys can plan well and avoid that. Now, examples of reasons that is unavoidable. Contoh, when you go to the river pagi tu hujan. So what happened? If that day is raining, which is very possible kan, so plan B nak buat apa? Do we proceed with what we plan, like plan A, cuaca cerah, or do we change our sampling regime? Now, don't forget now, let's say if Sungai Tua is raining heavy on that day, what will happen to that river? What do you think?
Air keruh.
Okay, keruh. So the quality dah tak sama kan? Kan? So these are the things that you might want to consider, But I would say not just air keruh, air kuat. So in Sungai Tua, for those who have watched the video or have been there, the flow of river in Sungai Tua is actually quite fast. So on that day, if it rains, I don't think you can even go near. I don't want you to accidentally fell into the river, hanyut, habislah. Because we don't have life jacket. Hari tu memang tak ada life jacket. So safety is number one. If it rains very heavily, I would recommend you all to just cut down the number of samples that you need to take. So to reduce the risk of injury and also accident. So Haris and also Iqmal, consider ya, hari tu kalau hujan, nak buat macam mana? Because this is very possible. And lagi bahaya when we go to hulu sungai yang ada mata air. That one, be very careful. I don't mind you cut down the number of samples provided that you have a very good reason, like for example, safety. But for this one, the completeness here, it's very much part of the QN QC because we know some of the samples might not be valid and you have to discard. Air keruh is one example. If air keruh kan, no point lah kan because it doesn't represent the original state of that river because raining only happens just once. Then after that, air dah keruh. It actually kan, if that day is raining heavy, we are not supposed to proceed with field trip tau sebenarnya. We have to cancel. not because of safety, but because of the validity. If that day is raining heavy, memang tak valid dah air sungai tu. Air samples maybe, yes, but even air samples also, some people also might question because what? Every time the rain comes down, you're also going to like remove all the like contaminant particles from the air, so it might change. So in the end, some of the samples that you collected, if it is not the normal state of that river or the airspace that you want to collect, you might need to discard it. So that's why we're talking about you plan nak collect 30 tapi ended up you only have like 5 because of these many uncontrolled reasons. And also the other thing is that maybe as simple as you are the cross-contamination. Now, if you know that sample is already cross-contaminated, memang boleh buang lah. That's why. So how does it affect the quality of your data? Now, first of all, if you have a smaller sample size, that means validity dia mungkin kurang kot. Yeah. At least with a smaller sample size, it diminishes, it reduces your ability to conclude or make a very good conclusion. Because like we all know, a bigger sample size makes your data more robust. More robust, boleh dipercayai. If you're having a smaller sample size because of these many uncontrolled reasons that you have to remove the sample, that will going to affect the trustworthiness of your data. Like I said, now is a planning stage. Pandai-pandai lah you all plan how many samples that you want to collect. And even if you're affected by these uncontrolled factors, you still have enough number of samples that you can make a robust conclusion. Okay, so now, next one, the concept. Okay. So here is the follow-up of the completeness that we discussed earlier. Sampling design. Will samples collected at an outflow characterized condition in the entire lake? Statistically relevant number of data points. So how big is your sample size that you can, that is adequate for the specific statistical analysis that you need to do? So even though earlier that we have concluded that around 30 samples is enough, but 30 samples is the general thumb. Because if your area is very big, more than 30 is needed, depending on how big the area that you're covering. Okay. Because in this case, in terms of statistics, 30 samples is the minimum that you can calculate and also statistically reduce the probability of error, the random error. So how many samples that you want to collect in order to get 30 samples? So let's say if you're predicting that 50% of your samples may be contaminated and are unusable due to various factors, you maybe need to collect up to 60 samples. So let's say 60 samples, 50% terpaksa dibuang, you still have a minimum 30. Faham tak? So the idea of this, like, in order to meet this like criteria, this parameter completeness, the tips of planner usually is that you plan and collect twice as much as you need. Okay, you collect twice as much. Because the idea is like this. Let's say anything happen kan, 50% kena buang, tak sakit. You still have the minimum that you need for the analysis. But let's say hari tu baik. All 60 samples is trustworthy, valid. You boleh ambil and analyze all 60 samples. Are you going to analyze all 60 samples? Tell me what is your opinion. Kalau semua valid lah, 60 sampel, but you need 30, are you going to analyze all 60?
No.
Yeah, why you don't?
Amount yang kita guna untuk parameter tu tak sampai untuk seberapa banyak botol yang kita nak ambil itulah.
Okay, kalau cukup 60 botol, You ambil 60 botol, balik semua valid, tapi nak analyze 60 ke?
Kalau kalau untuk duplicate boleh lah doktor.
Okey, kalau larat kan? Betul tak?
Betul juga doktor.
Okey, kalau larat dan kalau perlu. Okay, now I have a philosophy like this one now. I akan cuba predict. I have like a worst case scenario, plan A, plan B, worst case scenario. If that doesn't happen, best case scenario, you dapat lebihan sample. You have more samples that you need. Now the question why we don't analyze all sample is because what for kan? Let's say 30 samples out of 60, separuh. Kalau separuh tu boleh bagi awak result yang bagus, ni tak ada keperluan nak habiskan duit awak untuk analyze semua sampel. So, ni nampak tak? It's the duit. Money. You analyze all sample, you buang duit. So, kalau 30 samples dah cukup cantik, kenapa kan? Itu satu, duit. Number two, manpower. Oh, by the way, manpower tu duit lah. Because you have to employ people to analyze that sample. But here's the trick. I will still collect more sample. Sebab kenapa? Okay. I akan pilih lah. Dalam 60 tu, I akan pilih 30 sampel yang agak, macam dia cakap duplicate tu. Duplicate dia ada dua kan. One sampling point ada dua duplicate. So you run lah setiap sampling point tu satu sampel dahulu. Tengok macam mana. Kalau result dah cantik, dia ada duplicate, tak run pun tak apa. Unless dia ada macam high random error in that sampling point. Kalau sampling point tu tinggi random error dia, then you pergilah balik, okay, sampling point yang sama. Ada tak duplicate lain-lain yang awak boleh check, masa tu baru awak run. So these are the tricks that we use in analytical chemistry. We sample a lot, but that doesn't mean we analyze all of them. We only analyze if the initial analysis comes back not so good, then barulah kami akan run selebihnya. So itu trik dia. Yeah. But in order to address this one, we always take 2 kali ganda lah minima samples yang kami nak tu. So in this case kan, macam ni lah. You all plan kan? Apa kata korang plan ambil samples 2 kali yang korang perlu. In your plan, tak semestinya ambil 60 kan. And during that time, then you buatlah cerita kenapa you tak ambil 60 and you dapat 30 samples kan. So these are the things. By the way, I can't really tell you this entire story right here, but harap you all faham lah ya kan. So what is this completeness is all about? Okay, so that is the point of completeness. Okay, now comparability. Now, I think in your field trip ni, dia tak ada sangat lah the comparability that you can make here unless you want to compare the data with another data from earlier field trip, for example. Like, unfortunately lah, Sungai Tua last time student dia tak ada buat field trip kat sana, so you can't compare lah. You are the first one to have the first set of data in Sungai Tua. But let's say you manage to contact DOE. If you manage to contact DOE and DOE have water quality index previously from Sungai Tua, okay, you can take that data, and once you finish your field trip, you pergi buat analysis water lab, and you get the water quality index with all the data from each 6 parameter. You can actually compare with DOE's result. However, are we comparing with the same protocol? Soalan. The answer is it may not be. Sebab I think I want to share with you one slide. Sebelum saya continue lah, I want to share one slide. Let me stop sharing. And I want to bring up one slide. Sekejap. Okay, let me share again. Full screen. Okay, are you looking at the slide entitled River Monitoring by DOE? Nampak tak? Nampak ke? Are you looking at this slide, River Monitoring by DOE?
Nampak.
Okay, so I'm going to show you lah the picture that I managed to capture from Facebook, DOE punya Facebook. So, okay. So, maybe you recognize this landmark behind, but I would say this river, or if you want to call it river, because dia ada tebing kan nampak macam terusan. But if you see LRT, that means it's somewhere in PJ or KL. Okay, now what happened is, these are the team of DOE officers coming to this part of the river, betul-betul tepi LRT station, to monitor the river water quality. But here's the thing, I want you to pay attention to their equipment. Sama ke dengan our multi-parameter probe? Apa yang dia pegang tu? Nampak? Sama ke? Nampak tak?
Sama tapi besar sikit.
That is a problem kan. Dia lagi besar. That means not exactly the same. Okay, let me show you another picture. Now, this is what they do when they drop it down. They are dropping this down vertically, which means that lepas ni kan, korang punya water quality parameter probe tu, it's long enough. You can also do the same thing. But I'm not sure whether the cable is that long for you to drop this high from the bridge. Okay, now this panel shows you that all the parameters that you want to measure is similar to the one that we have, the multi-parameter probe. So dah lebih kurang sama. But you see, this equipment ni, okay, by the way, the only thing that is similar is the Vandon sampler lah. This is what they do, the Vandon sampler. And nampak tak dia punya tangan tu pakai apa? Pakai glove kan? Water group, pay attention. Dia pakai glove. Vandon sampler still the same. Direndahkan. Sample bottle is as it is. Ada besar, ada kecil. Ada yang gelap. Water group also pay attention. And the way they discard it and their PPE. Nampak tak? Ada luminous tau. And then they wear glove. Tapi tak ada pakai mask. Okay ke? You evaluate yourself. But the equipments that we use here, semua adalah sama except for this one. You see, another team, another sampling activity. Dia punya display, the parameters are the same, but alat dia tak berapa sama lah. This one. Alat dia tak berapa sama, in which you can see that DOE is using a very high-end, a higher-end equipment, bigger, more robust, jauh lebih besar daripada kita punya multi-parameter probe. Now, here's a question. Are we using the same equipment with the same capability? That is the question that I want the water group plus the QNQC group to discuss. Apa yang mereka guna tu tak sama. Ya, tak sama. Apa yang diguna tu, they do on the reporting. But the question is our equipment good enough to give us a data that we can compare with DOE punya data? You already have the user guideline kan? Okay, water team, you already have the user guideline. You already know what is a brand and model number. Your job, go and find out. Find out how good is that multi-parameter probe, and if you get the pH, the DO, and whatnot, boleh tak kami guna data tu dan compare dengan DOE punya data? This is a big task jugalah that you need to find out. So that is all that I want to show you here regarding the equipment. Now I come back to our original slide, which is the comparability. Okay, so coming back to the same thing, equipment. Why are we concerned about comparability is that logically lah, some equipment are better. They are better and more accurate. Itulah persoalan dia. Is our multi-parameter probe sama accurate ataupun cukup accurate that our data can be compared with DOE punya data? Okay. So what you're seeing right here, if you don't know lah, this equipment over here, this equipment over here is Hatch Portable Spectrophotometer. We have a few in the water lab. Korang ada guna tak photometer ni? Ada tak? Ke belum?
Ada.
Ada buat kan? Okay. Do you know that the photometer that you have used before sebenarnya dah tak accurate tau? Korang tahu tak?
Tahu, Puan Yus bagi tahu.
Okay, so itulah. Our portable photometer dah tak accurate. Sebab tu, we are not bringing this. Oh, by the way, this actually, you can bring to the site tau. And you actually can determine whatever that you want to determine using this photometer. It is portable sebenarnya. So you can bring to field trip if you can. But since this photometer, the one that is in water lab, is no longer accurate, no point lah kan nak bawa ke sana. Now the good news is we already ordered a new unit, cuma tunggu dia datang lah. I think by the time you buat FYP mungkin dia dah sampai kot. Anyway, this one is a photometer, this one is spectrophotometer. Why this is better is benchtop and is more accurate. So they can be used on the same thing. But based on the requirement, if you want your reading to be absolutely accurate, it's best that you bring your water samples back. But then again, ada sample yang you tak boleh analyze bawa balik kan, because like you said, water holding time, you have to analyze immediately. So bawa ke site, lower accuracy, tapi tak apa. At least kan, you have a better trade-off in a way that you manage to capture the actual data on the spot, and you are not suffering from the degradation of holding it too long, and you get a lesser accurate result. So in a way that these are the things that the QA and QC team together with the water team need to consider. You can do both. You can bring your sample back to the lab, but are those degradation time significant to affect the accuracy? If it does, then you have to pick a lesser capability equipment and you have to analyze on the spot. It's even better that you can analyze on the spot, because sometimes things can change very quickly. So these are the options that you want to consider and you want to pick. And during your presentation of your sampling and analysis plan, I will ask a lot of questions about why. Why do you choose that method? Why do you choose that equipment? Is that, and what is the reason? So a lot of things that you have to know, like tak boleh saja ikut orang, and you have to explain based on the requirement of your project. Okay, so QC for environmental measurement sensitivity. This one also relates to the capability of the equipment. Oh, yeah. When we talk about sensibility, you can say that this benchtop equipment is very sensitive. It can detect a very low level contaminants, whereas the photometer, they are portable, but unfortunately, they're not sensitive lah. So in the end, let's say in a situation where your water sample have a very low concentration, bila you detect dengan photometer yang kurang sensitif ni, they will tell you zero, tak ada apa-apa. Zero. But when you bring back to the lab and you analyze again using a more sensitive equipment, dia nampak sikit. Nampak lah. Sikit. But itulah kan. You also need to be very careful of what equipment that you have in hand. And is that equipment adequate? Sesuai tak? And in reality kan, I think even this one is voiced out by a professor in a research university talking about this, that a lot of students, they don't realize that the equipment that they're using is not sensitive and whatever data that they generate is like tak berguna. So before that happens to you, sampling plan. So kena plan betul-betul. Ask yourself, the equipment, if the level of the contaminants of the analyte is very, very low, is that equipment that you're going to use adequate to detect that very low level of the contaminants? So sensitivity lah ya, and this is where we are talking about the detection limit. And because of that, semua equipment, not just water group, air group also, and maybe others, you also need to ask yourself, your equipment sensitivity dia sampai mana? So the best way to measure that is the detection limit. By the way, every equipment, every instrument, dia ada detection limit dia, theoretical detection limit. You will need to note down this detection limit in your sampling plan. Okay. So macam saya sebutkan tadi, our water multi-parameter probe lebih kecil, adakah dia punya detection limit sama dengan probe daripada DOE? A big question that you need to ask yourself. And best of all, if you know the detection limit, you also need to compare back. Okay, let's say you predict the Sungai Tua punya air sungai tu tak tercemar, contaminant sangat rendah. Tapi tak apa, you are going to measure pH and DO kan? So the pH of river water, can it be detected accurately using your probe? That's number one. Another one, dissolved oxygen. Again, can it be measured accurately? I think I will stop for a while and ask the water group lah. Water group punya people, okay. If let's say that river is class 1, sangat sihat. Kalau sungai tu sangat sihat, what do you expect of the DO punya reading? Is it going to be very high or very low? Dissolved oxygen, if it's class 1. What do you think? Water group or anybody, sebab you also take water resource technology kan. Class 1, tak tercemar. DO macam mana? Tinggi ke rendah?
Tinggi.
Sepatutnya kan? Tinggi. Okay, there you go. Now, you have to have like a expectation. Korang kena ada macam prediction. Okay, air sungai tu, pH dia agak-agak berapa? DO dia agak-agak berapa? So, since Sungai Tua tu sungai yang sihat, pH dia maybe tak terlalu acid, tak terlalu alkaline, maybe around 7, neutral. Sepatutnya kan. Whereas dissolved oxygen sepatutnya tinggi. So kalau dissolved oxygen dia tinggi, that means kalaulah your detection limit rendah sikit pun, dia masih boleh detect, betul tak? There you go. So there you go. Your probe that you're going to bring, kalaulah sungai tu sihat, DO tu tak sepatutnya ada masalah, betul tak? Itulah dia. But then again, you have to find out the technical, technical documents of that equipment. Every equipment, they have like a certification. Dia akan sebut, okay, berapa sensitivity dia. Kalau dia sensitif sekian-sekian, berapa level of DO yang dia dijangka boleh baca. So you match lah. Kalau lah itu range yang dia boleh baca, you banding dengan laporan terdahulu daripada Jabatan Alam Sekitar, Sungai Tua, DO dia, level sampai berapa, you banding. If that previous report, the level falls under the detection range of your equipment, then okay lah, you can bring it. Okay? So always check the limitation of your equipment and also the river water quality that you're about to measure. Boleh baca tak? Kalau boleh, nyatakan. Kalau tak boleh, you still have to nyatakan in your sampling plan, yeah? Okay, so QC field, I think this one is more about the preparation that you do a day or several, I will say a day lah, not several days. A day before your field trip, sehari sebelum hari kejadian. Water group, you have to prepare this one. Prepare this only when you feel necessary lah. So apart from you collecting 60 in the plan, 60 sampling bottle, you also need to consider all these things. Type of QC like field duplicate boleh faham kan? Split sample, apa dia? After this we'll discuss. Performance evaluation sample and trip, equipment and cooler, temperature blanks. So you can see here, the keyword in QC usually hovers around 3 words. Duplicate, blank, and also apa dia, spike or standard. So dia tak lari jauh, ya. And for other students also, remember ya, dalam QC kan, 3 things will always come up. Duplicate, blank, and also spike or standard. So these are the things that you always have to know because, like I said, your final test memang akan tanya. These are the most important thing in sampling. So field measurement. Okay, now once again, you can see like type of QC samples like lab duplicates, berapa duplicate that you want to have. By the way, lab duplicates dengan sampling duplicate berlainan tau. If you're talking about sampling duplicates, that means dekat site, in one sampling location, dekat-dekat lokasi tu, you ambil lebih dari satu. 1, 2, 3. Kalau 3 duplicates, that is field duplicate. Lab duplicate ni is like you have one sample collected from one location at the site, bring back to your lab, and you split it into 3. Itu kita panggil lab duplicate. Dua-dua pun duplicate. So dia ada beza dia. Field duplicate and lab duplicate. QC, dua-dua kena ada. While the field duplicates is to determine the variation at the site for your sample, the lab duplicate is to determine the variation of the people who are working inside the lab. Okay, panjang cerita dia kan. Never mind. These are the difference. What about matrix spike? Anybody knows what is matrix spike? Or before that, let me see. Ada tak matrix? Oh, ada. Okay, never mind. That means I will skip this one and I go straight to next one. But before that, frequency. Frequency usually is related to time, but itulah nampak macam ada persamaan macam duplicate. Okay, I'll move on. Acceptance criteria. So what is a control limit? The corrective actions that will be done when acceptance criteria are exceeded. So acceptance criteria is like predicted values that you're about to have. It's more or less like a quality control. Like for example, if you expected your samples to give you a certain value, does it falls under that value? Usually when we talk about QC kan, when we test it, the value will be extremely accurate. If not 100%, 99%. So apa yang awak analyze, kalau dia tak keluar balik apa yang kami nak, that means wujudnya error. So sama ada error tu awak boleh terima ke? So dia ada criteria. And this criteria is none other the confidence level. Is it 95% or is it 99%? Most of the time is 95. Do you bring down the acceptance to 90%? The answer is usually no. But then again, semua bergantung kepada the authority or your client. Yep. So now, like I told you just now kan, QC ni, it hovers around 3 samples. The blank, the duplicate, and also the spike. Split sample ni sebahagian, blind samples ni is unknown. So before I continue, this image kan, have a look. Once again, the sampler tak pakai mask, dipakai luminous. Do you have to wear luminous during that field trip day? Or is there other PPE that you should wear? So water group, PK kan, yeah. But of course lah, they will always wear glove, yeah. So nanti tak perlu pakai mask lah, since these many pictures already shown, you don't need to. Okay, trip blank. What is blank? Now, blank is something that you want to compare. Blank ni is not a sample that you analyze. Although you're going to analyze alongside with your sample, using the same analytical procedure. But trip ni, nama pun blank, that means apa? What does it mean? If blank, what do you expect? Bacaan apa?
Zero.
Ada bacaan ke tak ada? Ada tak
Ada.
bacaan? Bacaan ada, tapi berapa?
Zero.
Yeah, blank. That means tak ada. Okay. Which means that your sample is having the analyte. You should see something. You should detect some reading. But blank, nama pun blank, nothing inside. So when you bring back to your lab, you expect no reading, or at least zero lah the reading there. So this is a comparison. Now, why do we have this? Reason very simple. Because the blank is a check on sample contamination, cross-contamination. Either you don't know kan, because the procedure kalau ada orang kumpul kan sambil level, I mean sometimes this cross-contamination can come from the sampler itself. You terbersin ke, terlebih cakap ke, air liur masuk air ke, it is possible. So these are the things that we have in the field trip, during field trip, bila dia ambil sampel tu, then these are the things to ensure that or one thing that you can ensure yourself that there are no cross-contamination, either from the sampler itself or maybe from the bottles. Believe it or not, bottles also can leach out contaminants. So these are the things that we need to have to ensure that. And sometimes, for some reason, we prepare this blank in the lab. Okay, we prepare this blank in the lab. We bring to the site and come back. Why? Because we want to see during the entire journey, sepanjang perjalanan pergi ke Sungai Tua dan balik tu, ada tak faktor-faktor lain yang menyebabkan berlaku cross-contamination? There are so many ways cross-contamination can happen. Yeah. Okay. So field blank is the blank that you fill at the site during sampling. So sampling too, like I said, also very similar to the earlier blanks, to determine whether there is a cross-contamination, namun pun blank, so you don't expect any reading. Now, the equipment or rinsate blank. Right. Do you remember last week when Amira demonstrated how to use Vandon sampler, and I told Amira that these are the technique to collect water sample, tapi belum masuk QC lagi. Belum masuk QC. And apa yang saya maksudkan QC itu is right here. Equipment or rinsate blank. Now, why do we care about this one? Once again, your equipment ni pun ada risiko berlaku leaching. Okay, that means there are something that comes out from your equipment as well. Maklumlah, the Vandon sampler tu dah lama, dah berkali-kali diguna semasa field trip, dan ada juga beberapa kali student tak basuh pun. So what do you think? Amira, remember your Vandon sampler sebelum you bawa pergi field trip tu, cuci dahulu. Rinse, and after you finish cleaning the Vandon sampler, you also just to check lah, selepas bersih sepatutnya tak ada leaching or cross-contamination kan from Vandon sampler. Tapi you have to do this, rinsate blank or equipment blank. Tengok alat tu masih bersih ke ataupun dia masih keluarkan kotoran. Because if they do, I mean, this is also beyond control lah, because alat dah lama, dia maybe akan keluarkan sesuatu, but we need to know what is coming out and how much. Because why? After you know that there's something is coming out and you know how much is coming out, you can actually do correction. But of course, you have to have this one, the rinsate blank. Yeah? Okay. So duplicate and replicate disenangkan. So duplicate, why is so important? We want to see the variation. Berapa besar variasi dia, especially when your sample, water, soil ke, they are not homogeneous. I mean, this is normal. Things will never be homogenized lah. It will change all the time. So if you know your sample is highly unhomogeneous, then replicate is the answer, as many as you can. Kalau larat lah. Yeah. Of course lah, replicate ni, we will calculate the standard deviation and determine how much of random error. Itu wajib lah replicate. Sebab tu I cakap, all your experiment can replicate because we want to know how randomized your data is. Split and blind. Now, when do you split? You have field split, you have lab split. So splitting these samples ni is usually applicable when you want to spike it. Okay, before I continue, I nak tanya lah, among all of you, how many of you know spike sampling? Why we do spike sampling, and what do we expect from the spike sampling? Pernah dengar tak spike sampling? Anyone who have heard spike sampling or learned spike sampling before, tekan raise. Saya nak tengok berapa orang yang pernah dengar spike sampling. Raise yang ada apa simbol tangan tu. If you know a little bit about spike sampling, tolong angkat tangan. I want to know how many of you. Afiq seorang. Afiq seorang je. Yang lain lupa. Okay, I just want to ask Afiq lah. Afiq, when do you learn about spike sampling? Masa bila dan subjek apa?
Sorry doktor, saya salah dengar tadi. Ingatkan doktor cakap kalau dengar slide doktor ni angkat tangan.
Kejap. Okay. Just tanya, since dah tanya Afiq. Afiq, pernah belajar spike sampling tak? Pernah tak?
Tak pernah doktor.
Okay, siapa di sini yang dapat PC Analytical Chemistry? Angkat tangan. PC Analytical Chemistry. Dapat PC, angkat tangan. Tekan raise kalau nak angkat tangan. Semua ke tak dapat PC? Lepas ni saya check. Are you sure you dapat PC? Lepas ni saya nak check. Ada PC. Siapa lagi dapat PC? Fitri, Syahira. I'm actually hoping Amira pun dapat PC. Amira dapat PC tak? Sofia dapat PC. Amira ketua water group dapat PC tak? Amira ada sini tak? Betul ke Amira tak ada sini? Kejap. Amira ketua water group kan?
Ya, doktor.
Amira dapat PC tak? Your analytical chemistry.
Tak.
Okay. Unfortunately, nak tanya you pun tak boleh dah. Tak apalah, I tanya Haris lah. Okay, Haris. Masa bila awak... okay, dah. PC awak dapat tu selepas ini kursus yang awak ikut daripada diploma kan? Betul tak Haris?
Betul.
Okay, dalam analytical chemistry tu, ada tak dia ajar apa yang saya sebutkan tadi? Blank, duplicate, spike. 3 ni. Ada tak?
Blank ingat. Duplicate. Duplicate dengan spike macam tak ingat sangat.
Okay, saya nak buat satu perbandingan lah. Okay, lepas ni, Haris masih ada bahan lagi, material daripada analytical chemistry yang pernah dibelajar. Bagi tahu saya balik, semasa awak belajar analytical chemistry tu, ada tak disentuh duplicate dan juga spike? Tak apa, lepas ni saya akan ajar jugalah what is spike. Tapi saya tak tahu because it becomes so dangerous because we expect you to know, but somehow many don't know here. So something need to be done lah dekat diploma side. Kalau tak diploma matrix. Anyway, okay, saya balik. Okay. I akan balik kepada the discussion. Okay, now why split and blind samples here? Because during the field, we can actually split your sample. Why? Very simple. Sebab water quality parameters kan ada 6. Setiap satu ada treatment dia blind. Ada yang hanya letak dalam 4 degree Celsius. Ada yang kena tambah sulfuric acid. Mungkin kalau you nak tengok lebih, lagi banyaklah different preservatives that you need to put in and preservation technique. Masa itulah I was split. Field split. Field split ni dia bergantung pada apa jua keperluan semasa analisis. Yeah. Because they don't preserve the same way. So that is for field split. Now lab split ni itu berbeza. Oh, by the way, some of the lab split and field split ni, they may share the same objective. Like for example, the spike, macam saya sebutkan, spike tu, bila kami nak letak spike, tujuan dia adalah untuk kita tahu sama ada teknik sampling maupun teknik analisis dan juga alat yang kami gunakan adalah tepat. So when we talk about spike, we're actually trying to measure accuracy. Sebab itulah during soil lab tu saya ada sebutkan error analysis, random error, guna standard deviation. You duplicate, you boleh kira kan. But not all the samples can be measured in terms of accuracy. Sebab when you want to know accuracy, you have to know exactly the correct reading from a correct sample. That is why spiking is done here. Now that spike tu, jamlah pada sini. Okay, spike is a known concentration of analyte is added to your sample. Contoh, kalau dalam sampel air korang dah tahu dia tak ada apa-apa kan, so nak detect apa, memang dia kosong pun, there's no contaminants. What if you want to detect a certain level of maybe heavy metal? Contoh, inside your field sample that you have collected, you cuba letak sebilangan kecil heavy metal, contohnya copper. Letak copper. Okay. That copper yang you letak tu ngam-ngam 1 miligram. Okay. Tengoklah. Let's say in your bottle is 1 liter. Dalam 1 liter tu, you letak 1 miligram. So, inside that bottle that you collected, 1 milligram per liter, contoh. Or you also can detect the quantity. Like for example, if your water sample is sekian-sekian, you tahu exactly volume of it, you letak 1 milligram, that is your spike sample. So you know exactly inside there, there's 1 milligram copper. Bawa balik ke lab, pergi analyze, then dalam sampel air tu, you kena pick up lah, ngam-ngam 1 milligram. So bayangkan, kalaulah masa analisis tu tak dapat 1 miligram per liter, apa maksud dia? Senang kan? Kita dah masuk 1 miligram, mestilah dapat balik 1 miligram kan semasa analisis. Ini bermaksud there is inaccuracy in somewhere. Either during the field trip when you collect sample, or during the transportation where something happened to your copper or something happened to your bottle, or it could be due to in the lab, the equipment is no longer sensitive, rosak ke apa-apa ke, tak tepat. In some way, you know that based on this field spike sample or maybe lab spike samples, you know in what stage the contamination or the error, the systematic error happens. Panjang lebar saya cerita kan. So I'm not sure even if you know what is this. But for those who don't know what is spike sample, this is extremely important, especially when you want to defend that your data is accurate. Kalau nak defend data kita accurate, memang daripada spike sample ni. In which, selepas kami spike sample tu, kami akan kirakan 5% recovery. Kalau letak 1 miligram, dia kena dapat 1 miligram. Kalau dapat 1 miligram, that means the percent recovery is 100%. 1 miligram masuk, 1 miligram detected. 100% percent recovery. So once again, I've just mentioned to you a very important keyword, spike sample. Percent recovery is what you need to calculate from the spike sample. So water group, Amira, pay attention. Benda ni masukkan. Walaupun saya tak rasa awak kena buat, tapi awak tengok balik. Which of the 6 water quality parameters that you can do this, the spike sample? Because otherwise macam tak ada kan. Kalau you nak measure pH, soil pH, macam yang saya sebutkan hari itu. You will going to check with your standard, which is a buffer. Anything that you can check against the standard, or you know you can spike the sample, this is where you can kira lah. And to determine the accuracy of your result. Okay, I think that is the last slide that I have for you. You see, actually I want to stop sharing lah. Habis my lecture, ada setengah jam lagi. So all 61 of you, today we just learn again analytical chemistry sebenarnya. Whatever that you should have covered semasa analytical chemistry, especially mereka yang dapat PC, sepatutnya tahu tau what is blank, what is duplicate, what is spike sample dan macam mana nak olah. How do you play around with this data so that you can argue in terms of accuracy and precision. Benda ni kan dia bukan main-main tau. Memang setiap report wajib dilaporkan standard deviation and percent recovery. That is part of the analytic chemistry and also in every single report in environment, soil and water. So itulah. Again, still not too late. You're still working on the sampling and analysis plan. So take back what you've learned today and implement in your sampling and analysis plan. Okay, I think sepatutnya hari ini kena buat face to face, but I am preparing for the worst by having an online lecture sekarang. And the best part is dah recorded. So the water group and also the QC group have a good benefit lah by having able to watch back this video. Anyway, I also tried with the note taker. So tengoklah note taker tu dia boleh tangkap tak BM and BI at the same time. But I think that is all that I want to talk to you about water sampling. So water sampling hari ni dah tamat. Oh, yeah. Sebut pasal water sampling because we are going to Sungai Tua river monitoring kan. So that means surface water sampling. For the groundwater sampling as well as marine water sampling, I will arrange pre-recorded lecture sahaja. So you all can follow those lecture, pre-recorded ones. And even next week pun, for soil sampling, pun sama, pre-recorded lecture. So dah tak perlu datang ke faculty and jumpa face-to-face lah lepas ni. By the way, I would rather more interested on your sampling and analysis plan, the current group work, and also your latest draft. I want to see your latest draft beginning next week. So Jumaat hadapan, Haris dan Akmal, remember no, Jumaat depan, sediakan first draft. Saya nak tengok your sampling and analysis plan. Boleh?
Boleh, Doktor.
Okay.
Alright, Doctor.
Okay, so with that kan, itu saja untuk hari ini. That is all for today. Remember that you have a few new exercise posted in iDiscuss. Make sure you do it all. And okay lah, this Friday tak perlu jumpa lah. Okay, by the way, this Friday, I will be in the campus. Saya ada dekat campus. Kalau nak jumpa face to face still boleh. Tapi kalau tak ada, Jumaat minggu ni, I propose that you all have group activities lah. You all have group activities, preferably. You choose lah nak buat online ke, nak buat face to face ke. And then prepare lah, like I said to you, the first draft of sampling and analysis plan. Tak perlu jumpa saya pun tak apa. Nak jumpa ke Jumaat ni? With me. Perlu ke? Haris dengan Amal perlu jumpa saya tak Jumaat ni?
For me, kalau ada apa-apa, nanti kita orang check doktor. Tapi
Okay,
kalau
kalau
I don't know.
okay. Kalau perlu jumpa saya, WhatsApp saya. Sebab Jumaat memang saya akan datang office. Tapi kelas korang sendiri yang jalan lah ya. Oh, by the way, maksud kelas sendiri yang jalan, that means you still have to register attendance tau. You future still needs your attendance this Friday. Okay, itu saja. Alright, that's all for today.
Doktor.
Ya.
Lepas solat Jumaat, hari Jumaat ni doktor kiranya ada ke office lagi?
Ada sehari, one whole day.
Alright sir, thank you.
Okay, that is all for today. Thank you very much.
Thank you, Prof.
Thank you, Prof.
Thank you, Doctor.
Thank you, Doctor.
Thank you, doktor.